In this video, we're going to continue talking about the item displays in the log chart view and start looking at different ways of viewing that data. So we go over here to our log chart page. You can see we've got a log loaded up here. In the last video, we talked a little bit about how to zoom around in the graph and how to move markers and so on and so forth. So now let's talk a little bit about the data itself. Over here on the right, you can see the items that were brought in from ECMLink. First of all, to display any item, you simply click it to display it or undisplay it. You can also click the box up here next to Graph Display to show all items or no items. So it makes it easier to get rid of everything and then go through and pick what you want to look at. We'll look at just these for a second here and talk a little bit about what these arrow keys over here mean. For RPM, map, and load factor, you can see the actual values brought in from ECMLink, but you also have the ability, if we look at just RPM here for a second, to look at it in two other ways. One is VE break points. The other is DA break points. Now what VE break points are, if I come over here and look at the VE table, it's indexed by RPM across the top here, obviously. And at any point in this log, the VE that ECMLink uses to calculate fuel air ratios and all that are actually interpolated from a 4-cell group. So for at any point in this log, it's using values from 4 VE cells. Let's load up a default table here. Let's say we are at this point somewhere in the log, we're above 35 or 3000 RPM somewhere in here, and we're somewhere above 0 psi of pressure. That means somewhere in here it's going to get that VE value. And it does that by interpolating, doing a two-dimensional interpolation of these 4 values to come up with a VE value. So if I look back here at my log, I can actually look at VE, and let's say we're at this point right here in the log. My VE value is 0.83. Now if I look at my VE table, it's telling me that somewhere in this area right here is how it's getting that VE value. Now the actual 4 cells that it's using to calculate that, I can see up here, as well as the percentages of how it's getting that. So from 3000 to 3500 and 7.3, 9.2 is the group of cells that it's actually looking at to come up with that VE value of 0.83. Now back in the VE table, you'll see that 2 cells were highlighted, and what those cells are the 2 cells that are contributing the most to that VE. So up here you can see that both of those are contributing roughly 50%, because the reason is I'm so close to a map breakpoint that I'm basically in this 7.3 area. So both of those cells are contributing 50% roughly. These aren't contributing much at all. On the VE table I can see that right here. The actual 4 cells would be these 4. So in the log chart, this step view on the RPM right here tells me that I am in the 3000 block of the RPM, so I'm between 3000 and 3500. This number is the first block of that 4 cell group that I'm in. If I were to go right here to the very beginning of that cell, you'll see now that I've also dropped to a different map point vertically, but you can see RPM based, almost all of the VE error horizontally is being created in this 3000 cell. The reason is my actual value is 3019, so I've just barely crossed into the 3000 cell, so that a majority of my VE is coming from this cell right here. Now it works the same way in map values. If I go to map and look at VE values, you can see their stair step. So if I was to click on this point right where that VE cell changes there, you can see that my map position, let me get closer into that. At this point right here, most of the percentage of the map is up here on the top. That means I'm just barely into this 3.7 row of pressure, and you can see none of this row is really being affected at all. So if I look at my VE table, my 4 group cell would be this. Almost all the VE is coming from these 2 cells because I've just barely crossed into this row. Okay, so if I go to the middle of that RPM step and as close to the middle of this as I can get, you can see all the percentages are a little bit more even. Try it somewhere up in here. They're much more even at that point. So anyway, the stair step cells here just let you look at where you're crossing into and out of VE points with both manifold pressure and RPM. The program, when we start getting corrections and things like that, it'll handle all this automatically. It understands the contributing percentages of each cell in this four cell group. But sometimes it's kind of handy to visualize this so that you know exactly where you are at any given time based on the RPM and map. The same kind of thing works for the DA tables. If I go to the RPM selection up here and I select DA breakpoints and then go to load factor and select DA breakpoints, I now can see the indexes into the AFR and timing tables. These tables are indexed by RPM, and also over on the left they're indexed by load factor rather than manifold absolute pressure. And the RPM breakdown is different than it is on the VE table. You can see here it goes 0, 500, 1000, 1500. Over on the AFR and timing DA tables, it starts at 750 and goes in increments of 250 and then jumps to 500 above 2000. So that's what the DA breakpoints tell you. They're doing the same thing as the VE breakpoints were, except they're indexed into the DA tables. So anyway, that lets you look at those three parameters in a little bit different way. It's kind of helpful when you're trying to figure out exactly where you are in the tables. Some of the other things you can look at here, one thing that's kind of interesting is acceleration rate. This is something that ECMLink doesn't display, but LinkTools here it's calculating it. What this is an instantaneous acceleration rate based on the speed, the smooth speed that LinkTools does. And what it's telling you is, for example, at this point right here, my acceleration rate was roughly 14.9 miles per hour per second. So if I looked at my 70-90 times up here, you can see that as soon as I hit 70 miles an hour, for some reason my acceleration dropped just a hair, and there's probably a reason for that in horsepower or torque. You can see that something probably dropped, torque fell off, for example, and then it picked back up right there. Could have been a lot of things, but basically this is telling you what your acceleration rate is at any given time. And that's handy because it's just another way of measuring the performance of your car rather than just straight horsepower or torque. If you want, you can look at certain areas of the log and see how your acceleration rate has averaged over that period of time. If we look at raw values, you can see that it's actually calculating that based on about a half-second window. I currently have it set up to average acceleration rates over about between a quarter and a half second of time of speed samples, and then it takes that data and creates the smooth curve from it. Kind of take this with a grain of salt. You know, it's only as accurate as the speed data and the other parameters feeding into this, but as long as you're always looking at the same parameters on every log, you can use it for comparison purposes. So that's basically it in a nutshell as far as these display parameters and how the VE contribution display up here works. In other future videos here, we're going to get more into corrections and how to take advantage of this 4-cell group and do automatic corrections on the VE table and some other things.